Hello, and today we'll be discussing the unpacking of a sequence. So let's have a problem. You have an n element tuple or sequence that we would like to unpack in a collection of n variables. Now let's move on to the solution. Any sequence or iterable can be unpacked into variables using a simple assignment operation. The only requirement is that the number of variables and structure match the sequence. Let's have an example over here. P we have is equals to 4 and in the bracket we have 5. 4 and 5. Now let's have x comma y is equals to p. Let's see what is the value of x. Now let's move on to the value of x is 4. Now let's see what is the value of y. It is 5. Okay, so now let's move on to some more examples. Now let's say we have the data of, let's move on to, we have the data of Apple. Now we have the shares are 500 and the price is 55.5 and the date is 2023 we have 5 and we have 30. So now let's move on to that. Name we have, then we have shares, then we have price, then we have date, then we have data. Okay, then we have, okay, let's see what we have this in as a result. Let's have the name, we have this. Now let's have the date, it is this. So now let's move on to further details. So let's have the name, we have shares, we have the price, then we have the year, we have the month, we have the day, which is equals to data. Now let's move on to the date name, that is Apple, year is 2023, month is 5th and day is 30. So if there is a mismatch in the number of elements, we will get an error. For example, we have the P is equals to 4, 5. Now we have X, Y, Z is equals to P. Let's see, we have an error, need more than 2 values to unpack. Now let's have a discussion over here. So unpacking actually works with an object that happens to be iterable, not just tuples or lists. Now let's move on to further examples. We have S is equals to, we have hello, then we have A, B, C, D, E, S. Let's see what we got over here. We have A, then we have this, then we have B, then we have E. When unpacking, we may sometimes want to discard some certain values. Python has no special syntax for this, but we can often pick a throwaway variable name for it. For example, let's have an example over here. Okay, so if we go back, let's have this value. We have the data. Now let's run this. Now we have, okay. So we have underscore, we have shares, then we have price, then we have underscore, then we have data. Now we have shares. Now we have price. Okay, however, make sure that the variable name we pick isn't being used for something else already. Hello. So let's have a problem over here. We need to unpack some elements. Let's have some n elements from an iterable, but the iterable may be longer than n elements, causing too many values to unpack exception. So let's have some solution for that. Python star expressions can be used to address this problem. For example, suppose we run a course and decide to end the semester that we are going to drop the first and last homework grades and only average the rest of them. If there are only 4 assignments, maybe we can simply unpack all 4, but what if there are 24? A star expression makes it easy. Let's move on to that. We have the def, we have the drop, we have first, we have last, we have grades. Then we have the first, we have the star, middle, last we have the grades. Now let's have the return function average now. Okay, let's use another case. Suppose we have a user record that consists of a name and an email address, followed by an arbitrary number of phone numbers. We could unpack the record like this, that will be shown in the next lecture. So now let's have a problem. Let's have a use case. Suppose we have a user record that consists of a name and an email address, followed by an arbitrary number of phone numbers. We could unpack the record like this. Record, we have the name Sam, then we have the email address sam@xyz.com. Okay, now let's have the phone number. Then we have this, then we have the another phone number. Okay, so now let's have the name, email, the phone numbers, phone, user record. Okay, user record could not be found. Okay, so let's move on to the user record. So if we say that For example, if we have this, now we have this. Okay, user record is not found. We have the record. Let's have a record. Okay, so we have this. We have the name. It's the record over here. Hello to another lecture. So now in this lecture we are going to continue our discussion from the last lecture. So now it's worth noting that the phone numbers variable will always be a list, regardless of how many phone numbers are unpacked, including none. So the start variable can also be the first one in the list. For example, we have a sequence of values representing our company's sale figure for the last, for suppose 8 or 9 quarters. If we want to see how the most recent quarter stacks up the average of the first 7, we could do something like this. Trailing QTRS, current QTR, sales record, trailing average, sum, trailing QTRS, len, trailing QTRS, return average, comparison. Then we have the trailing average, we have current quarter. Okay, so let's see that. Now let's see that. Okay, let's see that. Trailing current we have 25, then we have 8, trailing we have this, current we have 4. Okay, let's discuss now. We have the extended iterable unpacking is tailor-made for unpacking iterables of unknown or arbitrary length. Oftentimes, these iterables have some known component or pattern in their construction. Like for example, we have everything after element 1 is a phone number, and star unpacking lets the developer leverage those patterns easily instead of performing acrobatics to get all the relevant elements in this iterable. It is worth noting that the star syntax can be especially useful when iterating over a sequence of tuples over varying length. For example, we have perhaps the sequence of tagged tuples. we have this, then we have the bar, we have the hello version, then we have the foo, then we have this, then we have def, we have do, we have foo, then we have to print this, then we have print, we have foo, then we have def do bar, we have s, then we have print, we have bar, we have s, then we have for tag, records, if tag, then we have args, then we have elif, okay, so now let's run this. Oops, we have the tuple calling. I don't know what is happening over here. We have to put the is equals to. Now I guess it's going to run. And yes, we have the hello everyone. So now let's have a problem. We need to split a string into fields, but the delimiters and spacing around the text is consistent throughout the string. Okay, now we have the solution. The split method of strings objects is really meant for very simple cases and does not allow for multiple delimiters or account for possible white space around the delimiters. In cases when we need more flexibility, we will use the read.split method. We have now the line. Let's import the re, then we have re.split. Re, then we have re.split. So let's have the discussion over here. The re.split function is useful because we can now specify the multiple patterns of the separator. For example, we can see from the example we have either the comma or the semicolon or space, which is called the white space, but it will be here a black space since we have converted this theme to black. We now which will be followed by any amount of extra white space. Whenever the pattern is found, the entire match becomes the delimiter between whatever fields lie on the either side of the match. Now when we will use the re.split function, we need to be a bit careful. We should do the regular expression pattern involving a capture group enclosed in parentheses. If capture groups are used, then the match text is also included in the result. For example, watch what will happen here. For example, we have fields, then we have the re.split, we have S, we have semicolon, so we have this. We have an error over here. Okay, so let's copy this down. Then we have fields over here. Now getting the split characters which might be useful in certain contexts. For example, maybe we need the split. Maybe we need to split the characters later on to perform the output string. Now we have the values. We have the fields. Then we have the delimiters. Fields, we have the values. Now we have the delimiters. Now let's return the line using the delimiters. We have some let's join v plus t for vt in zip So if we do not want the separator characters in the result, we still need to use the parentheses to group parts of the regular expression pattern. Make sure we use the non-capture group specified as, for example, like this. Now we have this. Now let's have the matching text at the start of the ending of the split. Okay, for example, let's move on to something interesting. Okay, so let's have a problem. We are trying to match a text pattern using regular expressions, but it is identifying the longest possible matches of a pattern. Instead, we would like to change it to the finding of the shortest possible match. Now let's have a solution for that. The problem arises in patterns that try to match text and clause inside a pair of the starting and ending delimiters, example a quoted string. So now to illustrate that, let's have an example. str pat is equals to re.compile. We have okay, before that, let's have something more interesting. Let's have the text. Let's have the upper Python. We have the lower Python. We have the mixed Python. Now re.find now we have this. We have the text. We have the flags is equals to re dot ignore case. So now let's have the re dot sub. Okay, so it is re dot sub Python. We have this. Now the example reveals a limitation that replacing text won't match the case of the matched text. So let's have def match case word. Okay, let's have this re dot sub Python match case snake text flags ignore case. So we have this error over here. Now let's move on to another example. Okay, for example, if we have the problem that we want to combine many small strings into a larger string, then what we will do? We have the paths is New York, not so we have now the joint paths. Now join paths okay, so we have dot join paths. So at first glance this syntax might look odd, but the join operation is specified as a method on strings. Partly this is because the strings we want to join could get some from any number of different data sequences.